Welcome to section 1.5. Today we're going to look at applications, and that means we're going to do a lot of word problems. Example 1. A piece of machinery produces rectangular sheets of metal such that the length is 3 times the width. Equal sized squares measuring 5 inches on a side can be cut from the corner so that the resulting piece of metal can be shaped into an open box by folding up the flaps. If specifications call for the volume of the box to be 1,435 cubic inches, find the dimensions of the original piece of metal. So what are we looking for in this question? We want to find the dimensions of the original piece of metal. So the first step is to read the problem and ask what we're looking for. We must find the dimensions of the original piece of metal. Step 2, let's assign a variable. We know that the length is 3 times the width, so let's let x be equal to the width in inches, and thus 3x is going to be the length because it's 3 times that of the width. The box is formed by cutting 5 plus 5 equals 10 inches from both the length and the width. Remember, we're cutting out 5-inch squares from each of the corners, so essentially we're cutting 10 inches from each of the length and the width. So let's draw a picture. We have, this is the original piece of sheet metal. This has a width of x and a length of 3x. We're cutting a 5 by 5 square from each side, and we're folding this up to create this box. Now this box is going to have a length of 3x minus 10. Again, the 10 comes from the 5 plus 5, which we're subtracting because we're taking away those corners. The height is going to be 5 inches tall because we're folding these flaps up. And the width is going to be x minus 10. Again, we're subtracting 5 plus 5, or 10 inches from the width. Now recall the equation for the volume of a box is volume equals length times width times height. We know the volume is supposed to be 1,435, and that's equal to the length, which is 3x minus 10, times the width, which is x minus 10, times the height, which is 5. Note that the dimensions of the box must be positive numbers, so 3x minus 10 and x minus 10 must be greater than 0, which implies x is greater than 10 over 3. If I were to set this greater than 0 and solve for x, I would get x must be greater than 10 over 3. And here, x must also be greater than 10, otherwise this expression x minus 10 would be negative, and you can't have a negative length or width. And so these are both satisfied when x is greater than 10. If x is greater than 10, well, the length would have to be a positive number. If x is greater than 10, the width has to also be a positive number. Now let's solve the equation we just created. We have 1,435 equals 3x minus 10 times x minus 10 times 5. Now I need to distribute and FOIL this thing out. So we have 1,435 equals, let's FOIL this out, we have 3x squared, negative 30x, negative 10x, plus 100 times 5, and then we could distribute this 5. So we have 1,435 equals 15x squared minus 150x minus 50x plus 500. Let's collect like terms. You have 1,435 equals 15x squared minus 200x plus 500. Now this is an excellent start. We can solve this equation now by setting it equal to 0 and see if we can factor it or use the quadratic formula. So let's give that a try. So we'll start with 1,435 equals 15x squared minus 200x plus 500 where we left off. And then we'll subtract 1,435 to both sides. This gives me 0 equals 15x squared minus 200x, negative 935. And now I can try to simplify this. Notice that each of the factors contains a multiple of 5. So let's divide everything by 5. And that will make it a lot simpler. So I have 0 equals 3x squared minus 40x, 187. Now I can try to factor this. I'm going to multiply 3 times 187. That gives me negative 561. And I want to figure out what two numbers multiply to get negative 561 and add up to negative 40. The two numbers are negative 51 and positive 11. So it took me a while, but I got the numbers. These two numbers multiply to get negative 561, and they do add up to get negative 40. So use your calculators and guess these numbers. Now what that means is I could rewrite this as 3x squared minus 51x plus 11x minus 187. Now we could do factor by grouping. We have 0 equals, and in this case we can take out a 3x to the front. I have x minus 17, and here they have a common factor of 11, so let's take out 11. We have x minus 17, and so this factors as 0 equals 3x plus 11 times x minus 17. Now we can use the zero factor property. I can set 3x plus 11 equal to 0 and x minus 17 equal to 0. For the first equation, we could subtract 11 to both sides and then divide by 3 to both sides. We have x equals negative 11 over 3. But remember, the width can't be negative, so we'll throw out that solution. On the other side, we'll add 17 to both sides, and x equals 17 is a good solution. Now, in step 5, let's state the answer. Only 17 satisfies the restriction of x being greater than 10. Thus, the dimensions of the original piece should be 17 inches by 3 times that, or 3 times 17, which is equal to 51 inches. Let's check to make sure our solution is good. The length of the bottom of the box is 51 minus 2 times 5, which is equal to 41. The width is 17 minus 2 times 5, which is equal to 7 inches. The height is 5 inches. The amount cut on each corner. So the volume of the box is given by length times width times height, or 41 times 7 times 5. And yes, it does equal 1,435 cubic inches like we wanted. So we know this is a good solution. Example 2 requires the use of the Pythagorean theorem for right triangles. Recall the legs of a right triangle form the right angle. Here we have the leg A and the leg B. These are the two shorter lengths. And the hypotenuse is the side opposite of the right angle. The hypotenuse is the longest side of the right triangle. And that is usually denoted with the letter C. The Pythagorean Theorem. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So the Pythagorean Theorem states a squared plus b squared equals c squared. So please memorize this formula, the Pythagorean Theorem. Example 2. A piece of property has the shape of a right triangle. The longer leg is 20 meters longer than twice the length of the shorter leg. The hypotenuse is 10 meters longer than the length of the longer leg. Find the lengths of the sides of the triangular lot. The best approach to example 2 is draw a picture. Label the sides. So give that a try, draw a picture, and label the sides. In step 1, we read the problem. We must find the lengths of the three sides of our right triangle. Let's assign a variable. Let x be equal to the length of the shorter leg in meters. Then 2x plus 20 is equal to the length of the longer leg, and 2x plus 20 plus another 10, or 2x plus 30, is equal to the length of the hypotenuse. Recall, the length of the shorter leg is x. We're just going to give that a name. And we know the length of the longer leg is twice that of the short leg plus 20 more. That's where we get the 2x plus 20 from. And we know the hypotenuse is going to be the length of the longer leg plus an additional 10 more. And that's how we got 2x plus 30 is equal to the length of the hypotenuse. So here is our picture. We have the leg is x, the shortest leg. The longer leg is twice that of the shortest leg plus 20 more. And finally, the hypotenuse is 10 meters longer than the longer leg. So we'll just add 10 to 2x plus 20, and that's how we get the hypotenuse is equal to 2x plus 30. Let's write an equation. We're going to use the Pythagorean theorem for this. A squared plus b squared equals c squared. And so x squared plus 2x plus 20 squared equals 2x plus 30 squared. And now we can FOIL this out and try to solve for x. So let's FOIL this out. We'll do the scratch work here on the bottom. We have 2x plus 20 squared equals 2x plus 20 times another 2x plus 20. We'll FOIL this out, and I get 4x squared plus 40x plus 40x plus 400. And if you collect like terms, this gives us 4x squared plus 80x plus 400. So this is what we're going to use to replace this part here, 2x plus 20 squared. We'll do something very similar for this. We'll write this as 2x plus 30 times 2x plus 30. So that's going to give me 4x squared plus 60x plus 60x. And this is going to give me 900. So please practice FOILing this out and make sure you get the same thing I did. We have 4x squared plus 120x plus 900. So we have 4x squared plus 120x plus 900 is the result of the right side FOILed out. So now we can replace these with what they're equal to. Again, I did scratch work here on the bottom, but make sure you do it on the side somewhere so your work doesn't look too messy. After we substitute the values in, we have x squared plus 4x squared plus 80x plus 400 equals 4x squared plus 120x plus 900. Now let's collect like terms. I have x squared plus 4x squared, that is 5x squared, plus 80x plus 400 equals 4x squared plus 120x plus 900. We will subtract 4x squared to both sides. Let's also subtract 120x to both sides. And we'll also subtract 900 to both sides. That sets our equation equal to 0. I have now x squared minus negative 40x minus 500 equals 0. And now let's try to factor this. We have to find two numbers that multiply to get negative 500 and add up to negative 40. And that's going to be 50 and 10. It has to be a negative 50. And so this is just a diamond method. We don't need to split the middle. The leading coefficient is 1. So we have x minus 50 times x plus 10 equals 0. And now we could use the zero factor property. And so x minus 50 equals 0, or x plus 10 equals 0. And of course you could solve each of these for x. The first one gives me x equals 50. And the second one gives me x equals negative 10. But the negative 10 doesn't make sense because we can't have a negative length. So we'll throw away that, and so we'll keep x equals 50. In step 5, let's state the answer. Since x represents a length, negative 10 is not reasonable. The lengths of the sides of the triangle lot are 50 meters. The longer side is going to be 2 times 50 plus 20, and that's equal to 120 meters. And the hypotenuse is 2 times 50 plus 30 equals 130 meters. All we're doing is substituting x equal to 50 into our side lengths, and we have the lengths of the triangle: 50 meters, 120 meters, and the hypotenuse is 130 meters. In step 6, let's check our work. The lengths 50, 120, and 130 satisfy the words of the problem, and also satisfy the Pythagorean theorem. You can double check. You could double check that 50 squared plus 120 squared is indeed 130 squared, so it checks out. We know we did this problem right. If air resistance is neglected, the height s in feet of an object projected directly upward from initial height of s0 feet with initial velocity v0 feet per second is given by the equation s equals negative 16t squared plus v0 t plus s0. Here t represents the number of seconds after the object is projected. The coefficient of t squared, negative 16, is a constant based on the gravitational force of Earth. This constant varies on other surfaces, such as the moon and other planets. If a projectile is launched vertically upward from the ground with an initial velocity of 100 feet per second, neglecting air resistance, its height s in feet above the ground t after projection is given by the equation s equals negative 16t squared plus 100t. This is the position function of our projectile. After how many seconds will it be 50 feet above the ground? To do this question, let's recall the formula that we were given. We know S of t equals negative 16t squared plus 100t. Now it says, how many seconds will it be 50 feet above the ground? That's our position. So since this is our position, we're going to plug that into our equation here for S of t and solve for the time. We have 50 equals negative 16t squared plus 100t. And I could set this equal to 0 by subtracting 50 to both sides. We have 0 equals negative 16t squared plus 100t minus 50. Let's divide everything by negative 2 just to simplify this expression. We have 0 equals 8t squared minus 50t plus 25. Again, we use negative 2 to divide by everything because I like that leading coefficient to be positive. So we have 8t squared minus 50t plus 25 equals to 0. Now, if you try to factor this question, you'll realize it's not possible, but I can use the quadratic formula. A equals 8, B equals negative 50, and C equals 25. So we'll use this and plug it into the quadratic formula, which we learned in the previous lecture. So let's use the quadratic formula. We have t equals negative 50 plus or minus the square root of negative 50 squared minus 4 times 8 times 25 over 2 times a. So let's simplify this. We have negative 50, that's 50, plus or minus the square root. And I can enter this in a calculator. 50 squared minus 4 times 8 times 25. That gives me 1700 inside the radical, and we'll divide that by 16. Now enter this in a calculator. I want to make sure if I enter this in a calculator to make this have parentheses on the top so that it does the top first, then divide by 16. So we'll do the negative one first. 50 minus the square root of 1700 divided by 16. I did it on the calculator. I got 0.548, and then we'll do it with the plus. So we'll do that with the plus sign now. 50 plus the square root of 1700 divided by 16. That gives me 5.702. And remember, the units for this is seconds. This is seconds. So why do we have two answers, 2 times? Well, think about this. We're shooting an object from the ground, and we're asking what is it 50 feet above the ground. Well, there's going to be 2 locations. It's going to be 50 feet at 0.548 seconds, and it's going to be 50 feet at another time 5.702 because it goes up and then it comes back down. So we know there's 2 times for this answer. Part B, how long would it take for the projectile to return to the ground? When the projectile returns to the ground, the height s will be 0 feet. We have the equation S of t equals negative 16t squared plus 100t from earlier. So now we can replace S of t with 0 and then solve for the time when it reaches the ground. That's when the position is equal to 0. Notice that we have a common factor here of 4. So let's factor out a negative 4t. And so I have 4t minus 25. And now we could set each of these factors equal to 0. Negative 4t equals 0, or 4t minus 25 equals 0. Solving the first equation, we have t could be equal to 0, which makes sense. We are starting from the ground, so the time is 0 when the object's on the ground. And then solving this equation, we'll add 25 to both sides. 4t equals 25. Divide both sides by 4. T equals 6.25. So we know it takes 6.25 seconds for this object to reach the ground. Again, it makes sense when we start at t equals 0, we're on the ground. And then when we shoot it in the air, it'll take 6.25 seconds to touch the ground again. The first solution, 0, represents the time at which the projectile was on the ground prior to being launched. So it does not answer the question. The projectile will return to the ground 6.25 seconds after it is launched. Example 4. The I-Ride trolley service carries passengers along the International Drive Resort area of Orlando, Florida. The bar graph shows I-Ride trolley rideship in millions. The quadratic equation y equals negative 0.00525x squared plus 0.0913x plus 1.64 models rideship from 2000 to 2013, where y represents rideship in millions and x equals 0 represents 2000, x equals 1 represents 2001, and so on. Part A. Use the model to determine ridership in 2011. Compare the results to the actual ridership figure of 2.1 million. Since x equals 0 represents the year 2000, we're going to use x equal 11 to represent the year 2011. And recall our equation, y equals negative 0.00525x squared plus 0.0913x plus 1.64. We're going to replace the x equals 11 into our equation at two different locations. We have y equals negative 0.00525 times 11 squared plus 0.0913 times 11 again plus 1.64. So please plug this into your calculator and then simplify. So plug this into your calculator. I got 2.00905, and remember this is in the millions, so this is approximately 2.0 million. So we have about 2.0 million people riding this trolley in the year 2011. And that's pretty similar to what we expect. We expected about 2.1 million. In part B, according to the model, in what year did ridership reach 1.8 million? This is what we need to do with 1.8. We're going to replace y with 1.8 in our equation, and we're solving for x. We have 1.8 equals negative 0.00525x squared plus 0.0913x plus 1.64. Now this looks like a difficult problem, but we can always use the quadratic formula. And in order to do that, I'll have to set it equal to 0 first. So let's subtract 1.8 to both sides. And now our equation should be equal to 0. I have 0 equals negative 0.00525x squared plus 0.0913x minus 0.16. Plugging in everything into the quadratic formula, we have negative 0.0913 plus or minus the square root of 0.0913 squared minus 4 times negative 0.00525 times negative 0.16 all over 2 times negative 0.00525. Now be careful when you do this. Simplify it slowly on your calculator. I would do inside the radical first. Figure out what is inside the radical first, and then use your calculator to add or subtract the top, then divide by the bottom. Check your work with the calculator. You should get x equals 2 or x equals about 15.4. Again, use your calculator. Double check to make sure you get 2 or 15.4. If you don't, make sure you send me an email so I can help you out on your calculator. The year 2002 corresponds to x equals 2. Thus, according to the model, ridership reached 1.8 million in the year 2002. This outcome closely matches the bar graph and seems reasonable. The year 2015 corresponds to x equals 15.4. The model predicts the ridership will be 1.8 million.